Alright, here we go. Last video of Chapter 5. This video is actually only one word problem, and I want you to try to answer the word problem on your own before you even watch the entire video. So, if you haven't printed out the word problem or at least looked at it online, I'd like you to read through it and try it on your own. All you need to do is use your calculator for pretty much the entire problem and just think a little bit when you look at some of the graphs and find your intersections and stuff like that. So anyway, pause the video and try it. So, first thing you had to do is obviously assign coordinates. So we have 1 minute. She is 425 kilometers away from Mars. After 2 minutes of her retro rockets being activated, she's 356. And then after 3 minutes, she is 293. Now, this goes right back to the very last video you had right before this, where you had to use your graphing calculator to take 3 coordinates and find the standard form equation. So, instead of spending time talking about that, that's what we did in the last video. All you have to do is set this up into your graphing calculator. Matrix A would be 1, 1, 1. Matrix B would be 4, 2, 1, and the third row would be 9, 3, 1. Matrix B would be your constants, 425, 356, and 293. And then obviously you would have your A, B, and C for matrix X. So use your calculator, and after you solve, you're going to find out that your equation for this entire word problem is d of t, because it did say write the equation expressing d in terms of t. So it's d of t is equal to, you would have found that a is 3. You would have found that b was a negative 78. And you would have found that c is 500. Now, if you did not get that, I suggest you try really quick and get that equation, and then use that equation to answer the rest of the problem. Okay? So if you need to, pause and retry it. For part B, it just says find the d-intercept and tell what number represents in the real world. Well, remember, your d-intercept in this case is your y-intercept, and that's when x, or in this case time, is 0. So 0, comma, if you plug 0 into this equation, you get 0 minus 0 plus 500. It's 500. Or you could just look at the table of your graphing calculator. Okay? In the real world, what does that say? Well, that says that's when she starts her rockets. How far she is away from Mars. Okay? So that would be 500 kilometers. Next, part C. According to the equation, where will she be at 15 minutes or 16 minutes? Again, this is just a graphing calculator problem. Just look at your table instead of the graph, and when x is 15, what's y? It's 5. When x is 16, what's y? It is 20. So then it says, does this tell you that she's pulling away or is she approaching Mars? So since the distance is getting greater now, that means this is when she is pulling away. Again, you could just look at the graph and see if it's getting towards the x-axis or away from the x-axis, but those are the values that you need. For part D, does your model tell you that Melissa crashed into the surface, just touched the surface, or pulls away before? Well, to make that question easier to explain, all you have to do is look at part E first. It did say graph it. So really, again, this is just another sketch. We start at 0, 500, and then obviously a great point to have for this would be the vertex, because the vertex for this problem is going to be 13 minutes, negative 7 kilometers. So that means right over here, she crashes into Mars. So, unfortunately, Melissa just crashed. And why Do you know that? Well, all you have to do is really say that the vertex is below the x-axis. Okay? So, unfortunately, we lost Melissa for now, but don't worry, she'll come back. She's superhuman. All right? Well, that's it. That's how you use your graphing calculator to answer a word problem. But the thing is you must get part A correct to get everything else correct. So use your graphing calculator. This is Longo, and I'm out. See you. Bye. Next video will be Chapter 6.